In this problem, a 2.5 gram of zinc strip were placed in a silver nitrate solution. So the reaction is the silver metal formed on the surface of the strip. Therefore, we know that zinc is more active than silver, therefore it replaces silver cation. As a result, we have the silver metal formed on the surface of the strip, and at the meantime we have a zinc become zinc cation and enter the solution. Okay, now we know that at the end the mass of the strip increases from 2.5 gram to 3.37 gram, and we're asked to calculate the mass of the silver and the zinc metal at the end. So first we need to write down the chemical reactions of this process. That zinc as solid react with silver nitrate as solution. As a product, we have zinc nitrate and silver solid. To balance it, we have two silver and two silver nitrate. To make things easier, we need to write down the net ionic reactions, which is zinc react with 2 silver plus cation to produce zinc 2 plus cation, here's a solution, plus 2 silver as solid. So the key information is that the initial mass changed from 2.5 gram to 3.37 gram. So why the mass of the strip increases? The reason for that is initially we have zinc, at the end we have silver. So let's look at this process. The way I deal with it is I want to know for every mole of zinc for this reaction. Okay, if we have 1 mole of zinc, hypothetically, okay, and we have enough silver to react with zinc. All right, so for 1 mole of zinc, we need 2 mole of silver to react. And initially, we have 0 mole of silver. If the reaction goes completely, the change of this process is zinc, 1 mole of zinc reacted completely, and 2 mole of silver plus reacted completely. As a result, okay, here we have 0 mole of zinc plus. As a result, we have 1 mole of zinc 2 plus and 2 mole of silver solid. Now let's look at the mass. Okay, so if we do it, okay, the mass of 1 mole of zinc is 65.39 gram. Okay, this is not molar mass, it is mass for 1 mole of zinc. And this is the solid, okay, and the mass of silver at the beginning, okay, of course 0 gram. And the change, if this mole of zinc reacted completely, we lose all the 65.39 gram of zinc. How about silver? Silver will have 2 mole of silver, that is 2 times 107.9 gram. Okay, so it's not per mole, it is gram. Okay, 9. Remove it. 1.9, 1.7.9 gram. Okay, so that's the gaining part. So what's the final? the final is we have 0 gram of zinc, hypothetically in this case, but we have 215.8 gram of silver. Now you can see for every mole of zinc that will lose, for every mole of zinc go through these reactions, will lose 65.39 gram of zinc. On the other hand, we'll gain 215.8 gram of silver. So what's the differences? What's the increase of the mass in this process? That is 215.8 gram subtract 65.39 gram give us 150.4 gram increase. Now we know for every mole of zinc reacted, it leads to 150.4 gram of mass increase. Okay, now what's the mass of increases in this case? That is, the initial mass is 2.50 gram of zinc to 3.37 gram. So the increase is amount. So let's get more space here. Okay, so the increase of the mass is 3.37 gram subtract 2.50 gram give us 0.87 gram. So we know for every 150.4 gram of increases in mass corresponding to 1 mole of zinc. Now we have 0.87 gram increases corresponding to how many mole of zinc? Then we use our ratio. That is 0.87 gram of mass increase corresponding to 150.4 gram. That's corresponding to 1 mole of zinc. Okay, once more, that we know every 150.4 gram of mass increase corresponding to 1 mole of zinc. Now we have 0.87 gram increases. This whole thing gives us the gram of zinc reacted in the current setup. And do the calculation, we have 5.8, pay attention to the sig figures, times 10 to the negative 3 mole of zinc. And this is amount of zinc in mole that is reacted, means disappeared from strip and enter the solution. Now we are ready to do the final calculations. So for every mole of zinc, we have 2 mole of silver produced. Again, for every mole of zinc disappeared, reacted, we have 2 mole of silver produced. With so many mole of zinc reacted, so what's the mass of silver produced? We can do the calculation that the mass of silver equal to, we start with mole number of zinc, and we know that for every 1 mole of zinc, let's do the correction. For every 1 mole of zinc, we have 2 mole of silver produced, and this gives us the mole number, this gives us the mole number of silver. We multiply this by the molar mass of silver, and we can get the mass of silver. Okay, here we go. We multiply this, a molar mass of silver, 107.9 gram, and give us 1.3 gram of silver. Actually, this is amount of silver presented at end. So how much gram of zinc remained? Pay attention that at the beginning we have a 2.5 gram of zinc presented, and we know 5.8 times 10 to negative 3 more of zinc reacted. This amount of zinc are gone. So we subtract the mass of this amount of zinc from the original 2.50 gram of zinc. Then we'll get the amount of zinc remained in the final strip. So the mass of zinc is 2.50 gram. That's the initial mass of zinc. We subtract 5.8 times 10 to the negative 3 more of zinc. We get the mass of this. We multiply this by the molar mass of zinc, that is 65.39 gram per mole. We do the whole calculation. It gives us 2.12 gram of zinc. Therefore, we are done with the problem. At the end of 3.37 gram of the strip, we have 1.3 gram of zinc and 2.12 gram, 1.3 gram of silver and 2.13 gram of zinc.